If you need help with solid liquid gases, phase changes, and conservation of matter, please watch this video. These are also your notes on the yellow paper. Okay, matter. Matter is anything that has mass and takes up space. So, matter can be observed. It can be observed for its physical properties and also its chemical properties. Matter is made up of atoms whose properties determine what it looks like and what it acts like. Reactivity is chemical, and observable properties are physical. So, the states of matter. Solids have definite shape and definite volume. The molecules are closely packed, and they're in a regular geometric shape and a pattern. They wiggle and vibrate. So they do move, but not around. They can't move from place to place. They just vibrate in their one spot. And you can't tell that it vibrates because the atoms are so tiny. So you don't see that the molecules are vibrating. Solids can be anything, element, compound, or mixture, as long as it has a definite shape and a definite volume. So gold is a solid as well as a brick. Even though gold is an element and a brick is a mixture, they're still solids because they have a definite shape and a definite volume. So solids can be elements, compounds, or mixtures, provided that it follows the rule. The next thing is a liquid. Liquids have definite shape, but they don't have a definite volume. I'm sorry, let's reverse that. They have a definite volume, but they don't have a definite shape. Their molecules are loose, so they can slide past each other. So you might hear the term flow. They don't have a definite shape, so you see some of these molecules, they're kind of sticking out. So it kind of looks like it's a square if it's in a square container, but it will always take the shape of its container. So if we change the container, then the liquid looks different because they have the ability to flow past each other. The gases have no definite shape and no definite volume, so they're very, very separated, and they have lots and lots of energy. They move super quickly. They always fill the container that they're in. Gases also could be water vapor, propane. You have a lot of gases on your periodic table. There's about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gases on the periodic table. Hydrogen, neon, helium, nitrogen, oxygen, fluorine. You have chlorine, argon. You have krypton. All of your noble gases in group 18 are gases. Radon, xenon, those are all gases because they don't have a definite shape, no definite volume, and at room temperature, they move very quickly and they separate. Plasma. Plasma has no definite volume and no definite shape. They're composed of electrical charges with large amounts of energy. For example, stars, sun, plasma, televisions used to be made of plasma, but today we don't make them from plasma anymore because plasma electrical charges move so quickly that the quality doesn't last forever. It only lasts for about 10 years when then the plasma has totally dissipated. And you could get a little bit more depending upon the use. Most of the universe is plasma. Solid liquid gases you can see in this picture, they look different. If you add heat, you can change them. So adding heat changes the phase of matter. So matter, though, cannot be created nor destroyed. We can change it. It can change, but it doesn't get destroyed. So what you start with, you always end with. It just looks different. So there are ways that we can change it. We can change it physically. If we change it physically, we change its size, shape, or color. Examples of physical changes would be freezing. So if I have ice, and this is melting, but if I have ice, I start with ice that's 120 grams in water. Once that ice melts, it's still 120 grams. I don't get more, I don't get less, because it's still the same molecules, they just change their state. There are several different phase changes that you need to know. Condensation, it releases heat. That means the molecules move slower. You're going from a really high energy gas to a lower liquid. So we're releasing heat, getting rid of it. Freezing is also releasing heat. You're going from a liquid to a solid, so the molecules move slower. When you absorb heat, the molecules move faster. So the slow solid moves faster when it gets heat, and it changes into a liquid. Not everything will undergo the phase changes. Sometimes heat makes a chemical change. But if there is a phase change, that means it's only physical because you made it freeze or melt because you can get it back again. Evaporation absorbs heat as well as sublimation. Your example for sublimation is like dry ice. You have carbon dioxide, which was a solid, and then you change it to a gas because naturally carbon dioxide does not want to be a solid, it wants to be a gas. So at room temperature, it's always a gas. So if you've made carbon dioxide cold enough, you can make it into a solid and then it'll absorb heat from the environment and become a gas naturally because that's what it does. Does anybody remember the opposite of sublimation? So you're going to release heat. It's going to go from a gas to a solid. That happens in places that are super cold, like Michigan maybe or Chicago. That's like a flash freeze, and that's called deposition. So if it's really, really cold out, you can get your windows can freeze. Whatever water vapor is present and it hits that cold, it'll freeze up, and that's called deposition. Okay, so if you are okay with this, then give yourself a 3 or 4 on your paper. If you believe that you still need some help, go into Google Classroom, go into your packet pages 2 through 10, or I believe are good pages to study this. And you can also go into Google Classroom to get some more ideas. You can do the study jam video, so you can make yourself a poster, you can read your notes over again, you can make yourself index cards. You need to do something to help you get a good grade. What are you going to do?